Hi everyone, welcome to video 3 of 3 of the Introduction to LiST video series. The focus of this particular video is to take a look and understand how lives saved are actually calculated within LiST. So if we only have one intervention, the calculation is fairly straightforward. It's what's addressed in more detailed in the second video. So we'll be looking at a multiplication between the cause-specific death times the change in coverage times the intervention of effectiveness multiplied by the affected fraction, and all of that together will give us lives saved. However, in LiST modeling as well as in real life, oftentimes we will be trying to implement or to increase the coverage of multiple interventions at once. And in that case, what we need to do is to make sure that the preventive interventions are processed first, and then the curative interventions are processed on the residual number of deaths after the preventive interventions. When multiple interventions impact the same cause of death, to get the total number of lives saved, we can process interventions in any order. But we would calculate the impact only on the deaths that were not averted by the previously applied interventions. If we want to know how many lives were saved by a specific intervention, so if we want to attribute the lives saved to a specific intervention, in that case we would process each intervention by itself and then normalize the impact to sum to the total from the second step. All of this will make a lot more sense as we go through this. So as I said, if there's only one intervention, for the purposes of this example, we have an intervention named intervention A, and it affects diarrhea death, and it is a preventive intervention. So for example, we have a baseline number of diarrhea deaths of 10,000, and we assume that this, or at least we have data that shows that intervention A was introduced, so that means the coverage was 0, and it reached all the way up to 50%. So we have a coverage of 50%, and we also know that the effectiveness of the intervention to reduce diarrhea mortality is 10%. So to calculate the impact on mortality, it's a very simple equation. We multiply that 10,000 times 50% times 10%, and we come to the conclusion that 500 diarrhea lives were saved by the introduction of intervention A. So it's fairly straightforward. A note here about affected fraction, if you're wondering what happened to it and where did it go. We assume affected fraction to be 100%. Because essentially diarrhea deaths could have affected 100% of these diarrhea deaths. So we've finished with intervention A, and now we want to introduce a second intervention, intervention B. It's also a preventive intervention. So to start off, our new baseline of deaths, we had the 10,000 for intervention A, but we've already saved 500 lives, so now we subtract those 500 lives from our 10,000, multiply that by the coverage of intervention B, which once again was introduced, so it went from 0 to 20%, and then we multiply that by our effectiveness, so this is a much more effective intervention. It's 50% effective. And then to calculate our mortality impact, we get to multiplying our new baseline times the 20% coverage times the 50% effectiveness, and we can see that we now have 950 lives or potential diarrhea deaths that were averted, so lives saved. You'll see that because both of these are preventive interventions, it doesn't matter if you do intervention A first or intervention B first. In both cases, you'll end up with a sum of the two that is 1,450 lives saved. So no matter the order, when they are both preventive interventions. And now we want to calculate the proportion of the impact that is attributable to A. So in order to do that, we will do a division between the impact of intervention A divided by the total impact. So the impact of intervention A, we've already seen it. So that the intervention coverage times the affected fraction times effectiveness. And then the total impact is the sum of impact of A plus impact of B. As we've said before, the affected fraction is 1 in all cases, so we can essentially disregard it for our purposes. And if we run that with the numbers, we come to the conclusion that the proportion of impact that's attributable to A is 33%. Because they're, well, you could calculate the same for B, but since in this case we're only looking at 2 interventions, we can just subtract from 100%. So the proportion of impact attributable to B is 67%. And now if you want to calculate the number of lives that are attributable to A and B respectively, we go back to the sum of the impact of A and B that we'd calculated earlier, so that 1,450, and we multiply it by that 33% or that 67% for A and B respectively. That's the proportion attributable to A. And then this final number gives us the number of lives saved due to the increase in coverage for intervention A, the 483, or intervention B, the 967. All of that works great when both interventions are preventive. If we now introduce a curative intervention, this time the order of interventions will actually matter. So in this case, we would look at the impact of A and B in whichever order, and then calculate the impact of intervention C only on the residual deaths that are left over after we've applied the preventive intervention. So along the continuum of care, impact is calculated along the way. LiST has some limitations as a tool. It has some data availability concerns. So if we don't have any data available, LiST cannot do any calculations on that data. So that can sometimes be a limitation. Data quality, the default data sources in LiST are high quality data. But if you're using your own data or have, essentially LiST will not improve the quality of your data in any way. It will make those calculations based on the data that you input into it. LiST also does not provide sensible scale-up targets, so it's really great to be able to visualize what would happen if we reach these very high coverage targets, but determining whether or not that is feasible, determining whether or not these are acceptable interventions in the country, and determining how much it would cost to implement these or scale up these interventions, that is outside the scope of what LiST can do. Not all interventions are included in LiST. Some interventions are included because there's not enough data available to support including them. Other interventions are not included because there's data that supports that they don't have any impact on mortality. So those are two reasons why some interventions might not be in LiST. And you'll remember in an earlier video, we gave a criteria that interventions needed to be feasible in low and middle income countries in order to be included in LiST. So if they're not feasible, then they're not included in LiST either. LiST cannot and should not be used as the final answer. It's estimation. It's modeled results, so it's not the absolute truth. The outputs also really depend on the inputs. So if the data quality going in isn't particularly high, then the quality of the outputs won't be particularly high either. As we've mentioned before, cost, feasibility, acceptability, all of those outside the scope of LiST. LiST is also not meant to be used to decide how to do anything. So LiST will model what would happen to mortality if your coverage targets were high, if your coverage levels were high, but it doesn't indicate how to get those coverage levels high, how to increase them. Also, context is incredibly important, and that information can come from people in the country, people who have experience in programs in that country, and program implementers. But LiST by itself as a tool does not give indication on how to improve coverage targets. Sorry, how to improve coverage targets. Yeah. But all is not lost. LiST does have some significant advantages. One excellent thing that LiST can do that no other tool can do at the moment is it allows you to look at the impact of multiple interventions on multiple disease causes. So there's no need to rerun a projection each time that you want to increase one specific intervention, do them one at a time. LiST will allow you to increase the coverage of multiple interventions at once, and it will also show you some interventions have impact on different types of mortalities, and this will be calculated by LiST without problem. It's evidence-based. We have taken a look at the data sources. We've taken a look at how they can be accessible to the public. It's validated. So LiST has had a number of validation studies that confirm that LiST estimates are reasonable estimates of reality of measured data. LiST or rather the data that's contained in LiST is published, and there are a number of publications that exist already that have used LiST. It's regularly obtained and updated and maintained. We have a team of folks who keep an eye on the literature to make sure that all the new research on effectiveness is integrated into LiST as it comes out, and also the default data sources are integrated into LiST as soon as they're publicly available as well. And this very important note as well, LiST is free and it's available in the public domain, so anyone can navigate to our website and download Spectrum and use LiST for absolutely no cost whatsoever. The default data sources are also very high quality. It's a very flexible tool, so the default data that's already in there has been vetted, so to speak, by our team here. It's high quality data, but if you do have newer data that you have more faith in, or data that you would like to use for whatever reason, the user can enter that data. And LiST also allows you to create new interventions. So if there are interventions that you would like to model and you have data to support why you would want to include that intervention, LiST has the capacity to allow you to create that intervention. If you want to identify intervention impact pathways, the LiST visualizer is an excellent tool to allow you to see exactly what interventions have caused impact what kind of mortality through which kind of risk factors, and it's a really great visual interactive tool to allow you to do that quick and easily. If you want to, once again, very quickly kind of visualize which interventions would have the highest impact in your country, that's available through another LiST tool called the Missed Opportunities tool. And that, once again, is a quick process to access and gives a lot of visual information for choosing which interventions to prioritize. You can also tailor the tool to look, if you're only interested in the impact of a single intervention, you can look at that. If you're trying to compare different packages of interventions, you can do that as well. If you're interested in multiple countries, that also is a functionality that's available in LiST. So there's really a good number of things that you could use LiST to do. Some final parting words for the additional features that exist in LiST. We do have a subnational wizard if you're trying to do any subnational level modeling. It's available to you. The Missed Opportunities tool, which I've touched upon briefly earlier, will allow you to quickly visualize which interventions would have the highest impact if they were scaled up to 90%. We have an equity tool which does something similar, but this time answers which interventions would have the highest impact if the coverage levels reached the richest wealth quintile as coverage data in the country. We have LiST costing to put a price tag on your interventions, and we also have uncertainty of analyses available on LiST. The resources that are available online are the help files, which contain all of the data sources, the effectiveness data sources as well. We have a good number of training material, including this video. We have a user form to encourage users to post questions or to contact us directly. And we have a number of webinars and videos, such as this one, also available at the livesafetool.org. And if you have any questions and you want to reach out to us, our team address is info@livesafetool.org. I hope that was helpful. Thank you very much for your attention.